Hey everyone, thank you so much for joining in. Welcome to Edureka webinars. So in today's session, we'll be looking into the LSTM neural network. As we progress in today's session, the agenda is as follows. We'll understand what exactly is this LLP and ways to process the text data. And then we will understand about the recurrent neural network and the LSTM neural network, the use cases of the LSTM neural network, the real-time applications of this LSTM neural network, followed by a typical hands-on. So that is the agenda of this today's session. Now, when we talk about this deep learning certification course, this is how your learning journey would look like. You start by understanding about the deep learning, what exactly is this deep learning, the core concept of deep learning neural network, and this is followed by the how you will just generally get started with TensorFlow library. Next, you will proceed ahead and understand how to work with the convolutional neural network, followed by the RCNN algorithm, which is the regional convolutional neural network. Now, this is followed by Boltzmann machine and the autoencoders. And the sixth module is about the GANs, that is generative adversarial network. Seventh module is about gender and the emotion detection. And the eighth module is about working with RNN and GRUs. And ninth and 10th module is all about LSTM and applying the advanced algorithms, the combination of LSTM and CNN onto one of the complex tasks, that is auto image captioning. So that's how your learning journey with this deep learning certification training program would look like. As you can clearly see, you will be learning the basics, starting from the basics, and you go till the advanced to master this deep learning. Okay, so that's the benefit of this training course. So let's proceed ahead in our learning journey. And now let us understand what is this natural language processing. Now, when I say natural language processing, I can say that it's a subfield of linguistics. Here, what we are trying to do is we are currently concerned with the interaction between the computers and the human language. And we are basically interested in understanding and making the computers to analyze the text data. So that is what we are interested when we talk about the NLP, that is natural language processing. Now, when we talk about this text data, now this text data is a unique way of the data itself. It's not the same kind of data that we would observe in case of tabular format. The strategies that we need to use is very different in case of text data compared to the normal data. So let us see what are the ways that using which we can process the text data. Now, when we talk about text data, so I can make use of machine learning and find a way to represent those text data into a numerical format and then apply the machine learning on top of it. Now, when I say machine learning at this point of time, we'll represent the text data into numerical format, and then we will try to find the pattern between our given data set and the target. And that's where the algorithms would come into picture. It will make use of various features that we have converted into a numerical format, and using which it will find the representation between the input and the output. That's the scenario of NLP using the machine learning algorithms. And just like we can use machine learning algorithm, we can also use the deep learning algorithms as well. In case of deep learning algorithms, what it means is instead of using the statistical model, we'll be using a structure that is actually called as deep learning neural network structure. We'll make use of the complex structure of deep learning neural network to find the pattern that is present in the text data. So when we build such deep learning neural network, so we'll be extracting the high level features in the initial layer and also go deeper as the layer goes inside. So that's the overall intuition when we talk about working with deep learning. Okay, now here when we talk about working with the text data, so if we make use of machine learning like approach, In that scenario, the responsibility of processing the data would lie with us. And not only we have to process it, even in case of machine learning, so it will just use the text as a features and find the output. It is not capable of finding the relationship between the text data and understand understand the data in the format of a sequence. That's one of the common challenge that we face while working with the machine learning. And that's where the sequence-based architecture would come into picture. Now, one such sequence-based architecture, which is based on deep learning that we have got, is the recurrent neural network. Now, this recurrent neural network, what it has is it has got the recurrent connections. So the output from my previous neuron is being sent as the input to my current neuron. So as a result of this, whatever that has occurred in my previous input and the previous processing, that will be used as an input for the current processing. So if I am processing the data at this stage, let's say X2 stage, then in that case, while processing the data for this X2, I'll also consider the input from the previous stages like X0 and X1, because if we look into it, we have the connection which flows to this neuron of A over here. So when it is processing the X2, not only it has got the information about the X2, but also about its previous inputs, like for example, X0 and X1 as well. That's one of the main benefit and the main differentiating factor compared to the machine learning or in general, the deep learning neural network. So as a result of this, we are able to learn the complex patterns in the data set in a much more effective way. So because of this, this RNN makes it a clear choice when we are processing the sequence data, that is the text data. The reason because if you think about it, let's say if I've got a sentence that says as Rama went to forest. Now, if I've got a sentence as Rama went to forest, at that point of time, if I want to process that particular text data, I cannot process the individual words independently. The reason is, like, if I want to process the middle word, let's say went to, if I want to process the word to, I should know who is actually going to the forest. So I should remember my previous words when I'm processing the word to. So that is the power of the, that is one of the key criteria that we generally consider when we are processing the data set that we have. Okay, so that means not only we need to remember what is my current input, but also we need to remember what has happened in the past. And this kind of ability while processing the text data is being given in the scenario of this recurrent neural network. So because of this ability, we see the usage of recurrent neural network in especially on the complex tasks like speech recognition, natural language processing. In all those applications, we see the usage of deep learning neural network. Okay, using my sequential characteristics, I'm able to learn the patterns in my given data set in a much better way. That is the overall intuition behind this team. Now that you know the reason as why this recurrent neural networks is used, so let's proceed ahead in the learning journey. Now, one of the key challenge that we would face, especially while working with the recurrent neural network is here in the case of recurrent neural network. Okay, so like since I have to remember about my previous input with the inputs from the intermediary data, it is very difficult to remember the data for longer sequences. So since it is very difficult to remember the data for longer sequences, even when we implement it for the real life data set, at that point of time, the performance from the algorithm will not be as per our expectation. So that's one of the key challenge that we would observe when we are working with the recurrent neural network. And another challenge that we would observe while working with the recurrent neural network is the problem of vanishing gradient and the exploding gradient. So because of all this problem, we generally want to uh, find a model which is better than the recurrent neural network. So because of all the disadvantages, so the researchers came up with an other network architecture that's called as the LSTM architecture. Now, with the help of this LSTM architecture, we are able to solve the problem related to not able to capture the memory for long sequences. So with the help of this long short-term memory, the network architecture is now capable of remembering the data for longer sequences, but also the shorter sequence as well. That's the reason we say it as long short-term memory. So we have the ability to remember it for both long as well as the short-term memory data as well. Okay, that is what we would observe. And this long short-term memory in a neural network architecture, it's used in the field of deep learning. So in this case, so even this LSTM has got the feedback connection. Okay, that is the overall idea right here, team. Next, another thing is, so it can not only process the single data point, but also process the entire sequences of data in an effective way when we are talking about this LSTM network. So these are the key aspects of this LSTM, that is the long short-term memory. And here, this is the comparison between an RNN unit and the recurrent unit. So in the case of RNN, so I'll be sending my input of my current timestamp. Along with that, I'll be sending the hidden layer output from the previous timestamp. Hence, that is mentioned as HT-1. And using this, I'll be generating the hidden state. And then we'll pass out to the output layer to generate the output of that individual recurrent neuron. But when we look into the LSTM unit, so I'll be sending X1, HT-1, as well as the state that is CT-1. So we'll be working together in the format of a network so that we'll be able to capture the long-term sequences or the long-term relationship that is present in my given data set. So that's one of the key benefit of working with this LSTM based neural network. Okay, so because of this advantage, so we see the usage of LSTM in many of the application. It is used in search engine. It is used in analyzing the text data. It is like as per like this Siri was actually the application which has integrated the smart assistant into its operating system, and this is used in voice assistants, the LSTM network, and so it is used in Google voice search. Like it's not just in even even in Google, which we have got, even it has been used over there, the LSTM use cases. So those are all the applications of the LSTM neural network, like the applications where Google search, like wherever we want the complex text data has to be read and understood. That's where the usage of this LSTM neural network. And when we look into the real-time applications of this LSTM neural network, it is used in named entity recognition. So named entity recognition is one of the tasks in natural language processing, where we'll be interested in locate and classify the named entities. Okay, so it can be the predefined categories like the person name, organization, location, medical codes, quantities, monetary value. So these are the various predefined entities that we want to identify in the text data. In such scenarios, we will be using the LSTM neural network, which are very good when it comes to handling the complex structure in my given text data. And it is generally used in sentiment analysis, where we are required to process the text data and classify the incoming text data as like what is the overall sentiment, whether it is a positive or a negative sentiment, where we will be extracting the information in the source data and identify and classify the given data points to one of the classes. Okay, that's the sentiment analysis. We have it is used in machine translation. So like to analyze a large amount of text data and translate it from one language to the another language. So that's where we make use of the LSTM neural network. So these are all the various applications of this LSTM neural network. Now let me just give you a quick walkthrough as how does the code of this LSTM neural network would look like. So this is the example of an intent classification using LSTM neural network. So where we'll take a text data and we are interested in classifying as to which intent that the given text data is belonging to. That means this is a text data. And after I read through this text data, I want to classify as what is the target. So first we'll start by downloading the data set and we'll display the data set. Once it's done, we'll start by performing the pre-processing. So we'll perform the one-hot encoding and transforming our given data set and convert the text data into a lower case so that we can format it in a required manner. Then we will go ahead and split the text data into the individual tokens, that is my individual words. Post that, we want to go ahead and continue with the analysis, continue with the pre-processing, removal of stop words. We will remove the punctuation from my given data set. Now, once that is done, here I'm applying the stemming on the given data set by initializing the porter stemmer and applying the stemming on this given data set. When I say stemming, it is converting the text data into its base format. Okay, we'll perform the stemming on this given data set, and then we will use a tokenizer to convert the text into the sequences. We'll perform the padding. The reason because whenever we are working with the text data, not every sentence in my text data will be of the same length. And the common practice that we do in case of deep learning is we will perform the padding so that we bring every sentence into a common scale. And then we can define how we have to perform the padding. Then once that is done, we'll transform the text data, which is followed by LSTM network. Now this is a cell where we are building our LSTM model by considering our input data set. Then we'll go ahead and perform the training. Now once I've performed the training on my LSTM model, you can see that, see, I'm able to get the AUC score as 0.99 for this given data set for the training as well as the test data. And if you look into the overall classification report, we see overall accuracy that I'm seeing it as closer to like F1 score itself is closer to 99%, which is an excellent one that we can observe on the given data set. So this is just to illustrate that how this LSTM neural network can be applied on the text data and able to perform the activity of classification in a much easier and a better way compared to a general method. So that's the power of deep learning when we start working on any kind of data. And this is an example that I've shown you on its application on the text data. I hope you now have an understanding as why LSTM is generally used when we talk about working with the text data. So with this team, we come to the end of today's session on learning about the LSTM neural network. Thanks a lot, guys.